Now we're moving on to principles of economic equivalence. So one of the first principles is that common time basis is required when conducting economic equivalence calculations. So when you do any economic equivalence calculation, when you're trying to compare cash flows, you need a common time basis. So you can't really compare period 2 with period 3. You can't compare because that's not fair, right? You want to make sure that whatever it is comparable at the same time. So if your future worth at this period is equal to $100, for example, and your future worth at this same period is equal to $150, you would choose this one. Likewise, not all your cash flows will be the same. Your cash flow over here might be maybe $200, in which case you would choose this cash flow. And in this particular cash flow may be chosen at period 2, but if your period is 4, for example, then you have to do the analysis again. What is the value at the 4th period? And then you'd pick the highest value then, because you always want the most money, right? So you would have to compare the periods. It's not fair for you to compare the 3rd period of this cash flow versus the 1st period of this cash flow and the 5th period of the 3rd cash flow. So that's pretty much what the first principle is about, and we'll do examples to understand this much clearly. Now that we have a sense of what economic equivalence is, let's just drill the concept by doing a simple example. Suppose you have $2,000 and you want to deposit it at the bank at 12% interest, compounded annually. So what is the economic equivalence of your deposit 5 years from now? So it's at 12% interest per year, because it says compounded annually, and your initial amount or your principal value is $2,000, or your present value. So let's start by drawing out our cash flow diagram. You want to deposit $2,000 at year 0. And you want to know at 12% compounded annually, what is the equivalence of your deposit. So you just deposit $2,000 now, and you want to know how much it's worth 5 years from now. You want to take it out 5 years from now. So how much is it? So 1, 2, 3, 4, and 5. 5 years, right? Well, we can just use our compounded interest formula, which is future value. We're trying to find out the future value at 5, right? We don't need to write the year 5. Is equal to present value times 1 plus I to the power of number of periods. The number of periods is equal to 5. So N is equal to 5. I is equal to 12%. And P is equal to $2,000. So F is equal to 2,000 times 1 plus 0.12, convert the percentage to decimal, to the power of 5, which equals to this value over here, $3,524.68. Let's just do another example of time basis, common time basis. Suppose you are promised $5,000 5 years from now at 10% interest compounded annually. What amount would you currently require for it to be equivalent to $5,000 in 5 years? So what present value do you need now for that present value to be equivalent to $5,000 5 years from now? So you're offered one cash flow, which is you get $5,000, and right, this is 0, 1, 2, 3, 4, 5. So your these are your periods. This is one cash flow, and what I'm asking is, how much do you need now for the value to be equivalent to $5,000? So what is this value so that it becomes $5,000? So what is your present value? Well, we have our equation, which is f is equal to p times 1 plus I to the power of n, right? And we are trying to find out p. We have f and we have I, which is 10%, and n is equal to 5. So p is equal to f over 1 plus I to the power of n. And p is then equal to 5,000, which is our future value, divided by 1 plus 0.10, 10% to the power of 5. P is equal to 3,104.61. So if you have $3,104.61 right now, this is the exact same thing as having $5,000 5 years from now. Now, the next question is, what is the amount or the future worth at period number 3? When n equals to 3, what is the present value, or what does this value turn into 3 years from now? And what does this $5,000 future worth, turn into in the third period? And we are going to check whether it's equivalent, because we want to know if this concept of economic equivalence works, because it's the same cash flow, right? So they should be equal to each other. So we will start with the future value formula, which is f is equal to p times 1 plus I to the power of n, where p is 3,104.61, 1 plus 0.10 to the power of 3, because we're trying to figure out what the future worth is for the third period, which is equal to 4132.24. Now we're going to check if this value at the third period, so the third period equals to 4132.24, if this is equivalent to p is equal to 5,000. So now we're trying out the present worth formula, is equal to f over 1 plus I to the power of n. So 1.10 to the power of 3, or to the power of 2, right? So this is the fifth period. We're 2 periods away from this $5,000. So it's equal to, and it should be equivalent to this value, and it is. You may get, your answers may differ by maybe a decimal place or two, because your calculator is not calculating the exact value. You may have rounded this this present worth to 61 cents, right? So because of that, you may have slight difference, but the dollar amount should be equal to each other, which is correct. So this means that you can have a present value which can give you an amount in the third period, and it will be equivalent to you having a future value and that giving you an amount in the third period or any period. As long as you compare the same period, as long as you have a common time basis, you can compare the two cash flows and decide what is better. In this case, we compared the same cash flow, so they're equivalent. But if you had different cash flows, then they may be different and you would choose the higher one.